Sweet. So today what we'll be working through is the PRI motion sensor. It's a digital input, so you can see that what it's going to be doing is it's basically going to be detecting something that's going on in front of it on here. When we actually build it, we'll be able to kind of turn and manipulate it to where it'll be shooting out from it. Instead of just sitting there on this, it's kind of like this fake cone up above it, but it's a dome-ish that it's taking a reading on. Okay. So what it's doing is it's basically reading through to send a high or low signal, and then it's outputting to this light over here whether it detects something or not. Okay. So the PRI stands for passive infrared, which describes the technology inside. Basically, it passively detects infrared light levels and adjusts. It's similar to like a photo sensor, but not directly, and it's not directly in line with what's known as an IR direct detector or light. Yeah, so right now, so this defaults as outputting as low, which means that it's off. And then when it reads the amount of ambient infrared light, it'll trigger a high signal when it detects something's changing through it. Okay. So we can see this right here. So this is our sample circuit. Okay. So we're going to hit start on the simulation. See that the USB plugs in, so that means that it's got power. We have no activity over here. And then there's no activity on our PRI sensor. Let me do this so you guys can get to it. Okay. And then we're looking at this PRI sensor right here. Okay. So we're looking at this, we'll click on this and you'll see this ball in here. Basically the target is what we're looking at right there. That's currently where it's sitting at for an axis away from us. Okay. And what we'll see is when we move this, it turns on and it actively sensors it. Now you'll see that it has a range and it's not detecting it when it's outside that range. Okay. And then it'll detect it when it's inside of that range. Okay, so then we're outside. It'll give a second because it'll take a couple pips. And then now it's not detecting anything because we're outside of it. Inside detect, outside does not. Okay. Okay, so what we're going to be looking at doing, and this will be something that we'll get into once we actually go to build it, we can do different resistor size. Okay. And I'm assuming that's just for this side over here. There should be a way to adjust it. There is physically a way to adjust this and how far out in the sensitivity on the actual module, but right now we don't have that module. So I do in my little kit, but obviously it's not real. Okay. So the first thing that we're going to do is we're going to go grab an Arduino board. Okay. Okay. And now we're going to search for that PMI or PRI. We're going to grab a breadboard. We're going to grab an LED light and a resistor. Okay. Now what we're going to do is we're going to start placing this. So we're just going to pick a slot right here and we're going to connect it. You see that it's connected into 2 and then it's power and return in power. Okay. So we're going to get the 5-volt power from the other side. Okay. And then we're going to get a ground. Okay. And now we don't necessarily need this up here. Because we're not establishing anything on this side for right now. But it doesn't hurt to place it. And we're going to place this. And we'll see our resistor over here is 220. Our resistor currently right now is 1 kilo ohm. We're going to go to 220 by changing the ohms, or from kilo ohm to ohm. And then we're going to drop it in line with our negative on the bottom side right here, in line with our cathode. Okay. And then our anode should receive signal from 13. Once again, I don't like using 13, so I'm going to step down 1 and go to 12. Okay. Now this wire doesn't really matter what color. I'll put it in as orange. So our signal cable that's going to give us our output, we're going to put it in slot 2. We're going to drop it in line with this third one. Okay. The middle one's going to be power. So we're going to change that to red. And the last one's going to be ground. Or change that to black. Okay. Now we can see that through our walkthrough over here. Okay. So signal, power positive, power negative. Signal is 13. I changed mine to 12. And then resistor. Okay. So that's our setup. So we're going to hit next. Okay. So now we're going to go to the code and we're going to change, actually we're on our board. We can get rid of that side of our block. Okay, we're going to make it a little bit bigger for us. Okay. So we're on code. And we're going to create a new variable called sensor state. Okay. So we're going to set out, drag out set block. Okay. Okay, so that's this one over here. Okay. We're getting ready for some comments. So I'm just setting those up. Okay. So we have our sensor state. We're going to set block. We'll be able to store the state of our PIR sensor to sensor state variable. Click the input block category and drag out the read digital pin. Okay. So we're going to go to input block and we're going to read digital pin. And we're actually going to drop that in on that side right there. And we're going to set the pin for what we set the PIR sensor to. PIR sensor to. Okay. So then since our sensor connected to the output, or connected to the Arduino on pin 2, we changed the drop down. So we got that. We got our pin changed to 2. So we should say set sensor state to read digital pin 2. Sweet. So we're going to go to the control category and set up an if then block. Basically it's going to be our decision. If this happens, then this happens, else this happens. Okay. Okay. So then we're going to utilize our sensor state and using math comparator blocks. So we're going to go into math and we're going to be utilizing one of the comparator blocks. Okay. Now if you need to, you can check to see the comparator is comparing two options. Is this greater than, less than, greater than or equal to, less than or equal to, not equal to, or equal to. Okay. And our comparator block always looks like this with our carets at the end. And then you'll see this one here is and or are nots. We can come back to those. Okay. So what we're going to do is we're going to set this up so whether sensor state is equal to high using math comparator block. Drag out the math comparator block. So we're going to do this, drag this out, place it into our comparator, and then we're going to go grab our variable. We're going to go equal to wait, we don't have an option on that one. Oh, there it is. High. Okay. So we want to turn on the LED if the sensor is active. Otherwise, we want our LED to be off under the output block category. Find the built-in LED. So we don't want to use the built-in LED. We're going to use the set pin, and we're going to go to 12 to high. Okay. Else, we're going to set pin to low. Okay. So we can see based off of this that we're looking at. Okay, print serial to monitor, we can add that too. Okay. So this is the code that we just set up. Okay. So print serial monitor, not hello world. We want to go sensor. With a new line. Okay. So what that'll do is that'll hit a new line each time that it's changed. Okay. Okay. Now it's going to show us the text side of it. So we can go to the text. We can see that it initialized our variable. Okay. We see our void setup pin mode. We need it input for 2 because we're taking in input. Okay, we're pulling input from the PIR sensor to the board itself. Okay. And then we have output, so we're outputting to the LED. The serial begins, okay, 9600, that's for our serial monitor. And then this is what's going to be repeated for us throughout there. So this is where our sensor state is equal to the digital pin read, or digital read 2. So that's reading the sensor, and if sensor state is equal to high, write 12 high, and then print line sensor active. Else, digital write 2, low. Okay. One thing I'd like to do is so we can actually read it, we'll also set this and go sensor not active with new line. Okay. Now it's going to read it every 10 milliseconds. Okay. And then we're going to slide this back so we can see. We're going to change it back to blocks so we can see more of it on here. And we're going to run this simulation. Okay, we see it. Sensor's currently outputting not active. So if we click that, now if we start moving, we should see sensor activated. Okay. And then it should, once it's done reading it, should switch back to not active. Okay. Okay. Now this is getting into the setup for us on Friday when we actually go to build these. Well, when I go to build these to demonstrate for you guys. Okay. And that's eventually what our circuit will look like. Okay. Now what I want you to think about, and this can be something done throughout tomorrow, what else could you use this for? Instead of lighting up an LED, what else could you use it for? Okay, so that'll be our homework, is could we get something else to identify that sensor is active? Okay, now we haven't used what I'm thinking yet, so it'll take a little bit more of a setup, but this is what we're looking at. Okay, could there be something else that we could use instead of the LED to show that the sensor is active? Okay. So you can see that there are some sensors, so some adjustments on there for the strength and sensitivity of the board. Okay, and then there they are waving. Okay, so is there any questions? Okay. Since there's no questions, we are finished with today's lesson. For your homework exploratory side of it is, let's figure out something else we could use there. Okay. So there is something possibly on here that we could use to also create something that notifies us when the sensor is tripped. Okay, that's basically what we're doing, is the sensor tripped, or maybe a noise or something. Okay. Okay, so let's see if you guys can get those figured out, and we'll look at your guys' setups tomorrow, and we'll go from there.